In this video, I'd like to introduce you to a tool called Subnet Wizard, developed by Naem Azam. It's a powerful, console-based subnet and supernet calculator. Whether you're a network administrator or just a tech enthusiast, Subnet Wizard makes subnetting simple and efficient. Let's explore its features and experience effortless network calculations like never before. Follow along with me, and I hope you enjoy it. Let's break this down to make subnetting easier to understand. We start with the IP address 192.168.0.100 and a subnet mask of /24, which means the first 24 bits are reserved for the network and the last 8 bits are used for hosts. This gives us 256 possible IP addresses, from 192.168.0.0 to 192.168.255. However, 2 of these addresses are reserved. 192.168.0.0 is the network address, and 192.168.255 is the broadcast address, leaving 254 usable IPs for devices like computers, printers, etc. When we subnet further using a S26 mask, we're splitting the network into smaller chunks. Instead of one big network, we now have 4 smaller ones. Each subnet has 64 IP addresses, but again, we lose 2 per subnet, network and broadcast addresses, leaving 62 usable IPs per subnet. For example, the first subnet ranges from 192.168.0.1 to 192.168.0.62, and its broadcast address is 192.168.0.63. The next subnet starts at 192.168.0.64 and goes up to 192.168.0.127, and so on. By breaking down the network like this, we can better manage IP addresses in smaller networks. Let's walk through another example. Suppose we're given the IP address 203.0.113.0/25. With Subnet Wizard tool, you can get the answer in just seconds. But let me break it down in a step-by-step process of how we calculate these numbers. First step, we convert the IP address to binary. 203 in binary is 11001011. 203 is the first octet of the IP address. Each octet of an IP address is 8 bits long. To break down the binary of 203, which is 11001111, you can analyze it by looking at the powers of 2 associated with each bit position. Here's the breakdown of each bit's value. Sum of the values of 2 to the power of 7, 2 to the power of 6, 2 to the power of 3, 2 to the power of 1, and 2 to the power of 0 is 203. Binary of the second octet of 0 is 000000000. Binary of third octet of 113 is 011101. Sum of the values of 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, and 2 to the power of 0 is 113. And the last octet binary is 0000. To calculate the subnet mask for S25 network, we set the first 25 bits to 1 because we have 128 total addresses in the subnet. 2 to the power of 7 is equal 128, and the remaining 7 bits to 0. This gives us a subnet mask of 255.255.255.128. In binary, this is represented as 111111111.1111111.11111.10000. For the subnet size, since we have 7 bits reserved for the host portion, there are 2 to the power of 7, or 128 total addresses in the subnet. However, 2 addresses are reserved, one for the network address and one for the broadcast address, leaving 126 usable addresses. I hope my calculation note is helpful and not too confusing.